Hey guys, this is Professor Janacek. I want to go over an example where we find the volume of a solid of revolution. Remember, in this situation, we'll consider the volume to be area times thickness. So let's determine the volume of the solid obtained by rotating the region bounded by y equal to the cube root of x and y equal to x over 4 in the first quadrant and rotated about the y-axis. I've already graphed that, but real quickly you can see that y equal to the cube root of x, that's this line right here. And y equal to x over 4, that would be this line right there. And of course, in the first quadrant only. So we end up with this little shape here. If we rotate that about the y-axis, we get the full figure there. You'll also notice that I decided to analyze a little slice, a little piece of this going in the horizontal direction. I chose horizontal because this particular shape seems a little longer in the horizontal direction than in the vertical direction. Although if I set up the integral and it's not very easy to work with, then I'll go ahead and change the piece and go in the vertical direction and use that for my analysis. But looks like this is probably going to work out okay. So let's see. We know we are revolving about the y-axis. And this little piece that we've selected, that piece there, that is perpendicular to the y-axis. Which means, looking at our notes, about the y-axis, perpendicular to the y-axis, looks like we will integrate with respect to y and we'll use the area formula as pi r squared. By the way, this is referred to as the ring method or the washer method. Okay, so for volume, again, volume is area times thickness. Remember the thickness, since we're integrating with respect to y, then we can denote that thickness as dy. It's approximated by dy when we integrate. And of course our area is pi r squared. Now we just have to figure out what that r value is. What is the radius? Well, in this case, if we're looking at the radius, let's take a look. Our circles kind of go in this direction. There are the circles. And the radius would be from the y-axis out. So it's sort of like a y value. But you'll notice that our y values for these bits here, those y values go from the line x over 4 to the line cube root of x, or the curve cube root of x. And so our radius, we're going to take the outer one, which is x over 4. Actually, let me get myself a little more room over here. I'm going to need that. So it's going to be x over 4 minus the inner one, which is the cube root of x. Again, we're looking at the radius of those circles. Well, those circles are going to go just along from here, from this line to this line, or that one line to one curve. Okay, and so that's all good and fun. However, these values are in terms of x. I need them in terms of y. So for y equal to the cube root of x, x is equal to y cubed. And for y equal to x over 4, x is equal to 4y. So we're actually going to go from 4y, we're going to take 4y minus y cubed for our radius. That's what we're looking at. Okay, that's going to work out just fine. So back to our integral. We are integrating with respect to y. We've already determined, so we need to look at the y values. What are the limits of integration? Our y values go from 0 up to, well, that top line is y equal to 2. So we go from 0 to 2. And then we're going to integrate pi times our radius squared. Now, because these are squared, I need to square them before we subtract them. So we have 4y squared and y cubed squared. Now, I go over that back in one of the videos dealing with the looking at the ring washer method, what's going on with those, why those are squared. So take a look at that video if you have questions about that. All right, so there we go. There's our integral. We can clean that up just a little bit before actually integrating. Factor out that pi. 4y squared is 16y squared. Y cubed squared is y to the 6th. And we love to integrate polynomials. Make sure you're integrating, not differentiating. Often I see people go the wrong direction with that. So if we integrate 16y squared, we get 16 over 3y cubed. Integrating y to the 6th, we get 1/7 y to the 7th. We're going to evaluate this from 0 to 2. So let's see. 2 cubed is 8. 2 to the 7th is 128, I believe. 0 cubed is 0. 0 to the 7th is 0. Like those zeros in there. Oh, don't forget there is a pi in here. Let's just do that. Okay. And so let's see. We end up with 16 over 3 times 8. That's 128 over 3 minus 128 over 7. And there in the back is just 0. Oh, see, let's see. So 128 over 3 minus 128 over 7. That would be minus the 4. 4 times 128 over 21. There are several ways of going about this. Whatever arithmetic techniques you want to use, that's fine. Just going through it quickly so we can see. We should end up with, what's that? 512 over 21 pi. There we go. That is our volume. Now, typically volume has cubed units, but this particular example, there are no units. But if you had it on there, make sure you include them cubed. And there you go. Enjoy.